Hello there. The last part of statistics that we need to cover is the mean absolute deviation. This is very different from what we've recently covered, which were the different types of graphs that we were looking at, which were dot plots, histograms. We looked at box and whisker plots and stem and leaf plots. So this is more along the lines of calculating measures of center. So this is an additional measure of center that is not as well known as mean, median, mode, and range. This is called the mean absolute deviation. This specific measure of center is going to tell us how far away data values are from the mean. So this is dealing with the mean, which means in order to find the mean absolute deviation, we will need to have all of the pieces of the data set. So if we have a small mean absolute deviation, that means the data set is all close to the mean that we got. If we end up with a large mean absolute deviation, that means the values within the data set are more spread out. That will make more sense once we look at exactly how this is done. So there are some steps to finding the mean absolute deviation. The first one is to simply find the mean of the data values. This is no different than what we've covered before. Put the data in order from least to greatest, add all of the data together, and divide by the number of data points that you have or that you added together. Step 2 of finding the mean absolute deviation is to find the distance each data value is from the mean. So now we have a mean score, we have a mean for our data set. Then we take that number that we got and we look at each data piece and we look, how far away is each data point from that mean that we just calculated? The third step is to find the mean of those distances. So basically we find the mean again, just with these new numbers that we had just found the distance from. I should also remind you that for step 2, finding the distance of each data value from the mean, that would mean we would be doing subtraction. Okay, so let's see that in real time. For example, here's step 1. We get this data set and it's got numbers in it. We need to find the mean of the data values. Notice I've already got the data values in order from least to greatest. We have data values of 3, 6, 6, 7, 8, 11, 15, and 16. I'm still on step 1. I need to calculate the mean. I add each data value together. When I add all of those together, I get 72. There were 1, 2, 3, 4, 5, 6, 7, 8 data pieces. So I take 72 divided by 8 and I get 9 for the mean of this data set. 9 is the mean. The second step is to now find the distance each data value is from the mean. So that means I'm looking at my number 9 because that's the mean, and I ask myself, how far away is 3 from 9? 9 minus 3 equals 6. Okay, so I set this up in a table for this time. Here's our data values. Here's all of our data points from the data set on the left. On the right, we have the distance from the mean. So the data value of 3 is 6 away from the mean. The data value of 6 is 3 away from the mean, and so on. 7 is 2 away from the mean. The distance from the mean is what's shown over here. That was our second step. The third step now is to find, this is where we're actually finding the mean absolute deviation, meaning how far does this data set seem to differ from the mean. So now I'm going to take all of the numbers here in this column and find the mean of that to get the MAD score. So I look and I take 6, 3, 3, 2, 1, 2, 6, and 7. Those are all the distances from the mean, the distance from 9, which is our mean for this data set. And I'm going to find the mean. So 6 plus 3 plus 3 plus 2, these numbers are coming from over here, plus 1 plus 2 plus 6 plus 7 equals 30. There were 8 data points. 30 divided by 8 equals 3.75. That is my mean absolute deviation. That means that we are looking to see, are the values close to the mean or are they spread out? When we have a small mean, that means that our values are all relatively close to the mean. If we have a large mean absolute deviation, the values would be considered to be more spread out. Now at this time, continue on with your MAD practice.